Hi everyone. In this video course, I'm going to show you how to model in Rhino the small sport palace in Rome, engineered and designed by Pier Luigi Nervi. I apologize if I mispronounce his last name, I probably am. But Nervi was not only an engineer, but was very much an architect and an artist and cared deeply about building tectonics and aesthetics. He even wrote a book. This is actually one of the books that we're looking at. He wrote this, I think, in the 60s. You can find that on the Internet Archive, actually. It's called Aesthetics and Building Technology. And he had this balance of really exploring the aesthetics of geometric and structural expression while also exercising efficiency of material use and even labor use. And so this project that we're looking at here, it's called the Small Sport Palace, or I think it's Palazzetto dello Sport. I think it's probably mispronouncing it, but it's not that big. It houses around like 5,000 people. I think I could be wrong. It doesn't house that many people. It was built very quickly, and it was literally 100% built by hand. And of course, buildings are built by hand. But what I mean by this is that the dome structure that you see in this picture and in this picture here, it was literally prefabricated on site. The actual molds were made on site, and it was done quickly. And what's also just fascinating is that it all started out with a drawing of the lattice work. So they would draw on a piece of wood a sample of an extraction of the sphere, like a projection of the sphere, and make a mold out of it. And so if you see these diamonds here, there's about 13 of these diamonds. And so they made 13 molds on site and then started making all of these precast parts. And so if I scroll down here, this is, the end result, obviously. But this is like his patent system. He used like this ferro cement that you basically make this little tiny thin mesh of reinforcing bars, and then you squeeze concrete and sand or cement and sand together. And so it makes like this very like thin shell, right? And then you see here these little reinforcing bars stick out of it. And so you're basically casting the negative. And so if we go down here, you see right here, let me maybe zoom in so you can actually see what's going on. These are the precast members that are made from a mold. They're made from a masonry mold. And I'll go to another document to show you the masonry mold. But everything here is literally made on site and placed on site and poured on site. And so it's just absolutely beautiful because the end result is so beautiful. But this is what I mean when I say it was done by hand. Like it's like pure craftsmanship. This is parametric. This is like analog parametric. And I'm going to show you how to do this in Rhino, but in a very simple way. I'm not going to show you in Grasshopper. I'll just show you how to model it quite easily using very basic geometries and rules of geometry. You could definitely model this in Grasshopper, but I am just going to show it to you in a very basic way. But again, these are people working on site, and these are like the little reinforcing bars sticking out of the prefab parts, and then they would pour the negative, and that's how you get that ribbing. The ribbing is literally made by pouring inside this crevice here, right? And then they just pour the rest of the concrete over this, and it just becomes the mold just becomes part of the structure. And if I just go to this document here, you see this picture, it's just amazing, right? They're literally drawing on site, like by hand, the actual profiles on like this like piece of wood here, right? And then they will build the formwork off of it. So let me just show you the mold that they make. Here it is. This is a really good photo. Right here, they're using this mold. This would be like, how you make like a slip for ceramic, exact same thing. They're using this mold, and then they would build like this little cage system here, right? And then they would pour and these are the reinforcing bars, and then they would put like the cement and sand together through this. And so you see right here, that's like one of the molds here. This is absolutely phenomenal. So I'm going to show you how to build this in Rhino, and I'm going to keep it very simple. I'm going to use easy measurements. I'm not going to use the exact measurements. I'm going to use very close measurements. I might be off by like half a meter, but because I just want to keep the numbers clean. But I'm just going to use very simple measurements. And again, I'm not going to go into a lot of detail about every tiny part, but I'm going to show you the main structural systems and how to model them in Rhino. So let's just go ahead and get started. So the first geometry that we need to establish is both the plan and the elevation. And so you can find a lot of plans online. I'll leave all my sources in the description, but we want to establish the plan and the elevation. And the actual dome itself, it was first constructed from an approximately like 49 meter or 50 meter radius sphere. And then they basically cut a cord off of the sphere to establish a 60 diameter shell from that sphere. So that's the first thing we're going to do. And if you look on the right here, I have very organized layers. You need to be very organized with this. So the first thing I'm going to do here is I'm just going to go to my curved sphere and make that active. And I'm going to just go to my top view here. And I'm going to type in sphere. And it honestly doesn't matter which image I use here. I'll just use this one for now. And I'll just say this is my center right here. And let me turn my ortho on. So I'm going to draw a sphere with a radius of, I'm just going to keep the numbers clean in my opinion. So I'm going to use 50 meters. Okay. And then I'm going to go to wireframe. Let me just turn off image real fast. And then I'm going to draw a circle. Okay. And the circle is going to be from the center. And I'm going to give it a diameter of 60 meters. Okay. Now I'm going to take this circle and I'm going to extrude it through the sphere to split it off. So if I do ZS zoom selected, right? And I do split, right? There we go. So this right here is basically the top of the dome. Okay? Great. So let me just go back to top view. Let me turn on the image, right? Let me go to shaded. There we go, right? I can go to ghosted. So you see? Now, the next thing that we want to establish is the actual boundaries of the structure. So the outermost boundary is a 60 meter diameter shell, okay? But then the inner boundary of the lattice work is around like 4.5 or like 4.25 meters in. So what I'm going to do is I'm going to dupe edge and I'm going to offset in around 4.25 meters. Enter, okay? Let me change the layer of this, put this on solid sphere. Like that, okay. Now, this lattice work that you see here, it's made from a system, it's called a Lamella dome. There's a lot of different types of dome or lattice dome networks. And so one of them is called a Lamella dome. And even Lamella domes, there's different types. And we don't even need to trace this plan. I'm just using this plan as like a cross-reference, but I don't even need to trace this plan. But basically how it's constructed, let me just turn my annotation on. So the way it works is that if this is the radius right here from, let me go from here to here, like this. That's not nice. Like that. So we have this radius here. The arc is basically the same radius as this inner circle. Or another way you can think about it is the distance of the arcs is equal to half of the radius. So this distance here is equal to 1/2 of this distance here. And so what we can do, and this is divided by 108 lattice works, and it has about 36 columns. So if I do divide, let me go to my points. So these are 108, but right now it's going in between every other one, but that's fine. I can just press enter, it's grouped. So these, I need to rotate them about 5 degrees. Every column is about 10 degrees. If I turn my image back on, each of these columns is coming at like 10 degrees. But every other of these lattice works are at half of that, like 5 degrees. I can literally just rotate this over 5 degrees if I wanted to. See, I just typed in 5 degrees, and now I rotated 5 degrees. So if I go here, again, I'm not even going to trace this. I don't want to trace it. I'm going to turn it off just to prove like the mathematics behind this. If I draw a line from this point and go to the center, right? So if I do the arc command and I do the start option, I click S for start, and I click from this point to this point, and then I select the radius option, and I type in 25.75, enter, right? I can just click wherever I want it to be, right there, okay? So if I turn the images back on, you see? It basically follows the exact same arc. I mean, it's maybe off by a little bit. That's just because I'm rounding up my measurements. But if you notice, it's pretty much following the arc. It's parallel to the arc. But that's just basically the geometry, the rule of the geometry that I'm using. So then I just go ahead and I will mirror this like that, okay? Let me turn this image off. So now we have this. Let me just change the color of this curve because it's a little too light against the gray. After you have these two arcs drawn, we're going to join them. Just select both of them, just do J for join. And then after that, we're going to actually array polar 108 times. So you do array polar, select objects to array, enter. This is going to be the center point, 108, enter, 360 degrees, enter. Okay, great. And we can press enter to accept it. Okay, great. So after we do the polar array, we want to draw the termination point at the point of convergence for the lattice work. It sounds complicated, but this is basically what I mean. Let me go show you a picture. If you see here, you see how the lattice work goes, then it stops, and it becomes these straight joists. So it's about 6 of the lattice works before it does that, and you don't count the triangle, so it's like 1, 2, 3, 4, 5, 6, right? So if you count that, that takes up. There's about 13 unique diamonds here that use, and it's repeated all the way across. So if we go here and I count, right? So if I go here, it's going to be 1, 2, 3, 4, 5, 6, right here. So that means that this is the point where I terminate, right? I can draw a point at the intersection right there. You see? That's where it should terminate. So if I draw, and if you calculate it by actual measurement, it's around like 10 meter radius, like around there, 10 meter, 9 meter, 10.2, 9.5. It's around 10 meter radius. So if I draw a circle, and I'll show you, and I draw from the center point a radius of 10 meters, it's not going to be exact. It will be like almost there. You see? So I just need to go down a little bit right here. So I'll just draw a circle. I'll just do it by eye. Circle from the center point, and I'll go right here, like that. Okay? So this is where we know where it stops, right? Now, I only want, this is the only one I want, to be honest. I don't want anything else because I want to go back and finish this off as just like one complete solid piece. And then we can project it on as a surface, and I'll show you. So I'm going to go ahead and just select, I guess, let me just select this one. Let me just lock it and just delete everything else because I don't need it. I just needed to locate that intersecting point. That's why. It seems like we're going backwards, but we're not. You're going to see what's going to happen. Okay, the next thing I'm going to do is I'm going to draw a circle. That's like where the start of the cupola beam is. And I'm going to give it a radius of around 5 meters. And I'm going to offset it again 0.85. Like that. Okay, and then I'm going to draw a line from here to here and draw a line from here to here. Okay? And then I'm going to trim this arc off like that. Okay? So this is what we have. So this is like the straight edge here, right? You see? And so I'm going to trim this off now. I'm going to trim this like that. And then I'm going to join these two together. Join. And I'm going to offset B for both sides, 0.06. Like that. So we have this. Okay, great. So now what I want to do is actually, I want to do the curve Boolean command. So I'm going to select this, and I'm going to select these two curves. I'm going to do isolate. Okay? I'm going to do curve Boolean. And I want my output to be curves, right? So select curves. And combine region, yes. And I'm going to select inside of here. Enter. Great. So now I get like this closed curvature, you know? And I'm going to unisolate. So we have this. So I'm going to select this one here. And I'm going to select these curves as well. And I'm going to project them onto the surface. So I'm going to turn on my surface here, my sphere, like that. And I'm going to do project. I'm going to project onto here like this. Great. And so if I go and I do ZS, zoom selected, we have this piece here, which I want. You see how it's closed off? Now, what I want to do is I want to copy this surface and paste it. Control C, Control V, okay? And I want to split this surface with this. If I do split, I want to split that with this piece here. Like that, okay? Fantastic. Now, I'm going to delete this, right? And now we're left with, you see how we have this surface piece here? Right? Let me change this to solid lattice. Okay? And then I'm going to offset surface. And I'm going to select this surface. Enter. You see that I'm going to flip the direction. And the lattice is about 0.275 meters or 27.5 centimeters. Enter. There you go. So if we look underneath, you see? And it's a solid. And it's perpendicular, right? So now if we do array polar for this. So you do array polar. I'm going to select the center 108 times and just accept 360 degrees, enter. You get this. You see? So let me just go ahead and hide the sphere for a second. So this is what we have. Right? I think it looks very beautiful. I mean, this is looking, in reality, right? These are kind of curved. These are curved. I could have fillet before I projected it. I could have filleted this, but I just didn't feel like doing that because I just want to show you the basic principles of how to model this. Okay? Right? And let me just change the. I think it looks beautiful. Okay, so that's like the main lattice work structure. I'm not really worried about this piece. It's pretty easy. I can just split the surface, you know, and have that there. So we'll model that real fast. But this is like, you know, probably like 60% of the model. The next is going to be the columns, you know. If you notice, I haven't given a thickness to my sphere yet. I'll do that very last. But the sphere is around like 3 centimeters thick. So let's just go ahead and do this solid piece here. That shouldn't take that long. So if I go ahead, again, I'm going to copy this, paste it, and hide it. But because I always want to keep the originals of my geometry. This is just a basic modeling practice. I always like to keep the originals before I do anything subtractive. I can keep my history command on, but just in general, I always like to keep originals of like surfaces before I give them thicknesses or before I do subtractions or like Booleans, just in case I ever need to go back. So this here, I want to split this with this circle here. So if I do split, select object to split, I want to split it with these two right here. Okay, so now we have this surface here. Okay. And I can just offset surface down the same thickness, offset surface. And when we just flip it, it'll be, the distance is already saved. Let me just make that active so it keeps it. Cool. I can hide this. Like that. Cool. Now the next thing that I want to work on is the petals, the petaling of here. Okay? So if we look at the petals, look at this photo here, it's these right here. I have looked at a couple photos to determine whether this is curving or not. It's pretty hard to tell because in some photos it looks like it's curving. Other photos it doesn't look like it. Some photos it looks like it's a continuation of the sphere. Other photos it doesn't. But when you look at like the actual interiors, let me just toggle through here. You notice like a camber. You see there's like a camber to this. There's a slight arching to this. If I zoom in on here, you see? It's not the same distance all the way. It's almost, there's a camber both on the bottom and on the top. So I'm just gonna assume that it's also a projection of the sphere. This is another photo, but you see how like the thicknesses and the depths are kind of changing. There's like again a camber to it. So let me go to shaded. Okay. I actually want to split this sphere. So if I do split with this, so now I have this as a separate ring. Okay. Let me go back to curves lattice. Let me just turn off solid lattice. Okay. I'll just work off of this one here. Okay, I'm actually going to divide these. There's 36 columns on here. If we look at the image, any of these, there's about 36 columns. Okay. I'm going to divide this by 72 points because I need to go to the in-betweens as well. So it's like there's 36 of these, but the columns are forking, right? It divides itself. So you need to divide it by twice as much to find the reference points. And the same thing with the petals. So if I divide this, let me make my points active. I'll make that 72, right? So you see what's going on. You see? Now, what's important to understand is that it's around a 60-meter diameter hole, okay? In full, it's 60-meter diameter. But it is actually pushed back like half a meter here. It pins forward and pushes back, goes forward, pushes back. So we need to offset this in a half a meter. Offset 0.5 meters and go in here like that. And then I'm going to project this up as well. So I'm going to project this onto that like that. Okay? And I can also divide this by 72. Like that. Enter. Okay. So I know that the difference between this point, if I sketch this out, the difference between this point and this point is about 1.5 meters. So I can draw a line out from the center and go down 1.5 meters. That's one method. Or I can just subtract the total height distance from 1.5 meters, which is about, gives me a difference of like 1.36, right? So for example, if I draw a line vertical from here, and I go down 1.5 meters, right? This difference from here to here is what I'm looking for, right? So if I get a distance, it's about 1.3595, right? So if I draw, I can just honestly just draw that line. Vertical from here to here, okay? And I'm gonna move it. So this is the high point, right? So I'm gonna move it here, right there, to this point, okay? Cool. So now what's going on, let me go back to shaded and turn this off. So what's going on is this line goes like this, and this line goes like that. You see? Okay, great. So now for these lines, for the structure, I actually want to go to my top view. Okay? So if I go back to my top view, go to wireframe, and I'm gonna actually turn my project on. Okay? I'm turn my project on. I'm gonna draw a line, right, from here to this point, right? And I'm gonna offset both sides 0.06, like that, right? So it matches this. So then I'm gonna draw a polyline, a P line from here to this point here. And then I'm gonna draw another line from here to here. And then also I can draw another line from here to here. Or I'll save that. And then offset both sides like that. I want to clean this up a bit, right? So I'm going to go ahead and I'm going to select some things and isolate some things. So like I want to take these curves here, and let me go to perspective view real fast. So this is projected down. Don't forget we have project on, so it's drawn on the C plane. And I want to take this curve here and this curve here. I'll take these points. And I'll take these points as well. And I'm going to isolate. I'm going to grab this and just pull it up to, let me turn project off. I'm going to pull this up to here like this. Great. You see? And I'm going to just clean this up. So like I don't need these center lines anymore. Like that. I don't need those center lines anymore. Let me just extend these out. I can do curve Boolean and combine these all as one. Let me just extend all these lines out. Okay, and then go to top view real fast. Curve Boolean. Select this. I want to make sure combine regions is on, output curves, and I can just select, you know, everything here like that. You see? It'll basically give me a closed curve. I can show you real fast. You see? Let me just do height swap real fast. Right, I'm going to turn solid sphere on. Let me hide this top portion here. Right, I'm going to select this. I'm going to project this onto this. Right, so we have this. Again, I'm going to control C, control V, and I'm going to hide, and I'm going to split, right, this surface with that. Just delete, 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 delete. Okay. The reason, just so you can quickly understand, so we can get, let me change this surface to, turn this back on. So we get that, right? And then I can offset surface, flip it. Again, it's going to be 0.275, like that, right? And then I can array polar from the center 36 times, 360, enter. Now we have this. You see? We have to do the petals, but this is the beginning of the petals. So if I do height swap real fast, let me see which one I want to take. That one. Height swap. Right, let me just go here. Now we'll do the actual petals, okay? So the petals here, it has its own geometry and its own structure that's actually not following the lattice work. So if we go back and look at the photos, you see the actual petal piece, these two pieces are actually not as deep as the main members. You see? These are much thinner. So that's why I kept it separate, and even the petal geometry I kept separate. So if we go here, so we use this as our model. I'm gonna turn this off for a second. Just keep the lattice work. And let me do height swap again and grab my points because I hid them. Let me grab these points here. Just do height swap. Okay. So what I want to do, so there's this curve here that I want to take. So I'm going to draw a line, right, from this point here. I think I have these points in it as well. I should bring them back. Right. So I want to project this onto here, like that, okay? And then I actually want to draw a line from here to here, to this point right here, like that, okay? And now what I want to do, I can do a couple commands. I can do edge surface, network surface, sweep, loft, a lot of ways I can do this. I want to do the edge surface command. So I'll do edge, let me just make sure, yeah, edge surface, because you have to have open curves. So I can select this curve, and this projected curve here, right? And I'll get a surface like this, okay? Now, what I want to do is I want to actually mirror this. Like that, okay? And then I'm going to join these two, and I'm going to do fillet edge. And right now I have it pre-selected as 1 meter radius, which is fine, right? Press enter. So I want on both sides, like that. There is a curvature to this, and so it's around like 1 meter in radius, I would say. And so if I do the intersect command, I want to intersect this with this, and so I get something like this. Now I actually don't need this anymore. So if I do split, I can hide this because the actual true 60-meter diameter is from this point here. That's where it is. And I can prove it to you on Google Earth. I'll show it to you later. So what we have here is this and this, you see? And I want to go ahead and just array polar this and split it. So I'm going to select this, and I'm going to select this, and I'm going to isolate, and I'm going to do intersect this and this, right? And I'm going to do array polar from the center of this circle, just snap till you hit the center. There we go. I'll do it 36 times, like that. Enter. And I can do split, and the cutting objects be that. So I can just go ahead and just remove these now, right? I'm being silly. I can just lock this. Right? You get this. I'm going to make a new layer and call it Petal. Great. I can also array polar this as well. Array polar. You see? And then I need to do the two smaller pieces here that basically hits the midpoint. So if I draw a line from this point to somewhere on the mid like that, I'm just going to take it and I'm just going to project it onto this surface. There you go, like that. So I'll select this here and just, because it's already perpendicular to this, the gumball is aligned to object, so it's perpendicular. I'll just do 0.15. It's not that deep of a member. Rhino does this sometimes where it'll do the opposite, and it's kind of annoying. It's a Rhino 8 issue, but it's okay. So I'll just go down like that. And then I'll do offset surface. Both sides. I'll do like 0.03 because it's really not a thick member at all, to be honest. And then the same thing with this edge here. But let me call this Petal structure. Okay. Just mirror this on this side, and we'll also array polar this as well. So if I do dupe edge, join it. I can extrude it down. And I'll also just offset surface. So if I do select, let me select petal structure. Array polar. I'm gonna hit the center. Center. Enter. Great. So let me just turn everything on. Let me there we go. We have to do the ring beam. There's a ring beam right here. But that's just going to be pretty, like just guesstimated. But there is a ring beam there. It's such a beautiful structure, though. It's so elegant, so simple. Now, let me just open up Google Earth real fast so you see what's going on here. So here's Google Earth, right? You can measure things. So if I do like the projected measurement, I have it in meters. If I measure literally through the center, I can zoom in more. Right, from here to here, you see, it's around 60 meters, but it's 60 meters to the actual point. You see, the liftoff point, like the pedal. So let me just click somewhere like that here. It's 60 meters to this point here, but if you look at it in plan, you see it pushes back quite a bit. And that's where the columns touch as well. You see? So that's something to take into consideration, right? So that's the 60 meter. That's why I deleted that leftover piece, because you don't really see it anymore. And so now the columns, if you measure the columns, you get different measurements. Like if I measure on here, the projected is around like 8 meters projected. If I zoom, I can zoom in more and do it. So like, let me see. From like this point, yeah, it's like 8.6 or like 9 meters, And also if I measure the height, because you can measure 3D heights on Google Earth. very up close and personal here. But yeah, I want to measure this height right here. So let me get out of here. If I go to 3D path meters, I can measure from right here to right here. It's around like 8 meters, 9 meters. It varies, right? From the high point down. From the high point, I think because I clicked on a bush. 8.5, 9. It's going to vary. 7.86. And the ground is kind of sloping. So I'll just say it's like around 8 meters of height difference from here. Around like 25 feet, you know? Eight meters, 9 meters. I'll do 9 meters. That's what I'll do. I'll do 9 meters. So if we go here, right? So I'm going to take this curve here, right? This is the 1/2 inch and offset it out 9 meters, like this. Okay? And then I'm going to go down -9 meters as well, like this. And I'm going to divide it by 72. Great. And so the column is about, the column is also about like 9 meters in length. So if I go back to Google Earth and measure this, right? From like here to here. See, it's like 9.2. It varies, but the projected length is around like 9 meters, 9.5 meters from that long point. Right? So if I draw a line from here, I can do projected right now, from here to here. 9. Right? And then I'm going to draw a line from the midpoint, vertical. I'm going to draw it up around 4.5 meters, like that. And so actually, because I want to isolate some things, I want to isolate this and these points, these curves, and these points. Great. And so I want to draw a P line from this point to that point to this point here, like that. Now, I can draw a line from here to here, like this, and I can extend to see where it hits, like that. So it's like, it's a little bit short, you know? If I look at this, yeah, so I can trim like that. So we can deal with this length here. Now this is tapering, okay? So what I want to do is I want to draw a couple of curves here, a couple of rectangles. So right here, the width of the taper, I can measure it from here. I can measure it from here if I wanted to. If you see here, this is a great reference of the column cross section and the drawings. There's this Italian website that I found that actually has them. It's actually a great. This is like pretty well detailed. Open image, new tab. Right here. This is very detailed. But yeah, the column tapers. But it's and so basically this is like a reinforcement plan. And if you see here, the reinforcing bars are also concentric. They're leading down to the center. The main reinforcing bars are always leaning down to the center, like the I guess the vertical or lateral. You see? They go down to the center. And so I guess the arms of the column are also pointing towards the center. They're tapering towards the center. So that's really important to understand. And then this is like has like this leg that's here. Okay? Like that. You can go in and measure, the thinnest point here and the widest point here and the widest point here. And that's it. Or you can basically trace this if you want to, but I want to do it from cross sections of the thinnest and widest points. So I'm going to do the rectangle command and do the A for a round curve. And I'm going to select this curve here. I'm going to select this right here. And so for the length, I'm going to put in, which is, in my opinion, the depth. I'm going to put in 0.4. And then for the width, I'm going to put down 0.25. Like that. And then all the way down here, I'm going to do the same. I'm going to keep doing the same command. Rectangle, a round curve, select the curve right here. 0.35, 0.30, like that. That was 0.75, 0.60, because it does taper out. And then it actually like bows. So like if you look at this, what's going on is that in this elevation, there's like this point where it does that basically, It goes like this. That's what it's doing. So this pretty much stays the same, but then this is tapering out. So I want to copy this down. I'll go in negative 0.75, like that. Okay. So let me show you, we can loft this, right? Like that, you see? But it also, it starts to get even a little bit wider. So if I take this out, I can even measure it too, just to show you my workflow. This is like the widest part, right? So because it starts to flare out, and there's like a flap here. So it's like around 0.5, 0.4, because this is projected length, not true length. Just go up 0.5, right? So this should scale a little bit wider if I measure it, but it may not look proportional. That's my only concern, So if I go here and I go to images, it's like 1 meter. So I'll do like 0.9. I'm gonna draw a line out here, 0.9. move it from the midpoint. Still seems a little too wide, to be honest. I feel like it's going to flare out a little too wide, but it's okay. Scale 1D. Like that. So if I take this, I can take this one, this one, this one, this one, and loft it. Make sure the seams are all aligned, right? I'm going to do straight sections. I don't know why I was like that. And then I'm actually going to take this same curve and I'm going to copy and paste it twice. And I'm going to just scale 1D and go from here to the midpoint. Like that. But I'm actually going to just go in a little bit more than that to leave a little bit of the flat. Just a little bit, not too much. I'm doing this by eye, by the way. I'm doing this by eye. Let me turn the center snap off. In general, this line should be in the center of this, but I don't feel like doing it like that. Then I can just copy it. There we go. And so I'm going to cap this. I'm going to loft this to this. Make sure your seams are always aligned. You know? Okay. Same command. Loft this. Oops. I forgot to do so. Do rectangle around curve. Select this. Go here, and that's going to be 0.40 by 0.25. Loft this to that. You know? Mine looks maybe a little bit too skinny. It's okay though. And then the same thing for these cross sections here. I'm going to do a rectangle, a around curve, select here, 0.30, 0.25. Yeah. Just going to move it right there. And I'm going to do a polyline that just traces it. Because I know this is straight. Right. And I'm going to do the intersect command. Intersect this with this line here. Gives me that point right there. And so this curve here, I'm going to scale 1D. I'm going to scale it 1D from this point to this point, and it's about 0.30. Very wide, 1.35. And I'm going to move it from this midpoint to that point right there. You see? And then I'm going to do one more rectangle. Let me draw a line vertical. I'm going to go down 1.15. I measured these, by the way. So like if you're trying to know where you get these measurements from, I got rough measurements from these columns here. So if I turn this on, I'm measuring these. So like for example, this I'm getting the widest cross section here. I'm getting this cross section here, right? I'm getting this distance from here to here. I'm getting this cross section here, and then I'm just going to loft them. That's all. rectangle, a round curve, select curve. There we go. 0.30, 0.60. Move it here like that. And then I'm going to do loft. This. Again, you have to make sure your seams are connecting. So like, for example, I'm going to move all my seams to the back corner because they're all straight. Move that back there like that. Right? That's what I want. I want all of these like that. Right? I couldn't push this back more if I wanted to, because that's where it kind of aligns. And then let me just cap. I can select these, Boolean union. Cap that. I'm not sure if it's touched in it or not. There you go. All right, it's all one piece now. And then I can array polar this from the center. And isolate. So this is basically all of the structure. Right? It's very elegant. I think it's such a beautiful design. We can give the surface a thickness. So offset surface, it's around 3 centimeters. You know, same thing here. Like that. Okay, the other things that we can do on here is we can do the glass and we can do the little ring beam, which is pretty easy to do. And we can also do the cupola if we wanted to. This video is very long, so I don't want to prolong it even more. I think it's important to do the ring beam because that's part of the structure. So if we actually go back to the original, if we do hide swap, we can take the original right here, right? This is the original sphere. And we can also copy this curve, Control C, and hide swap. So we're going to paste it, and we're going to isolate it, right? So we have this curve here, okay? We have this curve here that's already been projected on here. So I'm going to offset like 0.09, and I'm going to do both sides. It's important, both sides, like that. Okay, so I'm going to take this curve and this curve that was offset both sides and project it onto this surface here like that. Cool. Now, it's a little hard. I'm going to zoom in on here. I want to take this one and this one. You see? Let me just group them. Split this surface from this. There you go. And then offset surface 0.275. Make sure I want to flip the direction. There you go. You just switch the layer to solid lattice. There you go. And then if we go inside, you see? We look at the photo. Go to rendered view. Got the beam there. So now we have a solid sphere. Let me just make this active. Right? We've got the petals, petal structure. Right? It's a beautiful structure. It's absolutely beautiful. Just so elegant, you know? It's super, like, can't believe this entire thing was built out of pieces. And then let's just do that. I mean, the glass has nothing to do with the structure, but I just want to do the glass. It's actually pretty good. Offset. Yeah. Like that. I should have, like I mentioned earlier, I should have probably pushed this back more, but that's okay. Right? And then if I do hide swap, I want to grab a couple of things, right? Like I want to take this curvature here, which is really important, and this curvature here, which is also very important. Bring that back here. Right, so I'm going to duplicate this down here like this. And first thing I'm going to extrude this up like 1.15 because there's like a solid piece to this, right? And then if you look at photos, basically extrude ellipse is like glass. You can extrude this up to this bottom edge right here, like that. I don't need this, right? Change this to the glass layer, like that. Can dupe edge. This. So I'm going to go ahead and join these. And then I'm going to intersect this with this edge here. You get these 2 points here. I'm going to dupe edge this one, and I'm going to split this curve with this point and this point, like that. And I can do edge surface, I can do loft, and loft this, like that, right? You get this glass panel here. And then same thing, array polar. I can do the mullions and stuff, but this video was really made for the structure. Array polar from the center. Well, actually, before I do that, I'm going to change the layer to glass. There you go. I hope you found this helpful. Again, this is really a study of the structural analysis of Nervi. I think that, I could have modeled the cupola, but I just didn't feel like it. It's more, I really want to focus on the structural of this more than anything else. And so it's such a beautiful work that everyone should study because we still apply these systems today. This idea of taking something regular and applying it like in a parametric fashion is something that we still do to this day. But it's amazing to see how people can do this by hand, just by drawing form. And if you found this helpful, please like and subscribe. It really definitely helps the channel grow. I really want to help out designers, architecture students, early professionals. Thank you.